This is a revision video for Chemistry 1, Alkenes and Polymerisation. Both alkanes and alkenes are types of hydrocarbons, but there are differences between them. This is an alkane, and this is an alkene. The alkanes only have single bonds, and the alkenes have the presence of a double bond. Most of the hydrocarbons in crude oil are alkanes. Alkanes are saturated hydrocarbons. Saturated means it only has single covalent bonds. So you can see that no more bonds can be made because all of the bonds are full. It's saturated. Each letter represents an atom, and each line represents a covalent bond between two atoms. So remembering covalent bond is the sharing of electrons. All of the alkanes have got the same general formula, which is CnH2n plus 2. So the number of hydrogen atoms in an alkane is twice the number of carbon atoms plus 2. So if you have an alkane with 3 carbon atoms, then to work out the number of hydrogens you would have to do 2 times 3 plus 2, which gives us 6, add 2, which is 8. So then that alkane would have the formula C3H8. Alkenes, however, are a family of hydrocarbons which are unsaturated. Unsaturated means they have one double bond. Alkenes have a general formula CnH2n, which means if we think about a molecule that has 3 carbons, like the example before, if we wanted to know how many hydrogens this has got, then we would have to do 2 times 3, which is 6. So the alkene ends up with having less hydrogens than the alkane because of this double bond here. If you want to test to see whether we've got an alkene or an unsaturated hydrocarbon, then we will use bromine water. Now, bromine water is normally a brown or orange colour, and when we add an alkene or an unsaturated hydrocarbon, it will turn to colourless. And that is how we know we've got an alkene present and not an alkane, because an alkane would not change the colour of the bromine water. Alkenes are really useful to us because we can use them to make polymers, which can then go on to make plastics. A monomer is a single alkene molecule. This one is ethene. And we can use it to make polyethene in a polymerization reaction. Because some polymers can be very, very long and made up of millions of carbon atoms, then we can't sit there and draw out the molecule. So what we do is we use a shorthand notation to represent it. And we would do our monomer, but without its double bond. So this shows that the double bond is being broken. And then we will put square brackets around the monomer molecule, leave the little arms poking out the side, and then we put an N at the end. And the N represents how many of the monomers we had to start with. We'd also put square brackets around the monomer molecule and then put a little N at the end. Now this shows us that this monomer has been reproduced that many times and they have been joined together to make this polymer. The naming of polymers uses the same rule every time. For example, lots of ethene makes polyethene. If we had lots of propene, this would be polypropene. If we have lots of pentene, this would be polypentene. And we can also use this rule to do it the other way around to work out which monomer has been used to make the polymer. Here we've got polystyrene, so that means that the monomer used to make this is styrene. Now, this is called addition polymerization. And during addition polymerization, unsaturated monomer molecules will join together to form saturated polymer. This reaction requires heat and a catalyst to take place, and it produces the polymer molecules, which we can then use to form plastics, which have got a variety of uses to us in real life.